Thank you all for attending. Today we will discuss simplifying large MCAD equipment assemblies for plant design integration and IP protection, webinar 2 of 3, focusing on the simplification of complex solids into primitive boxes, cylinders, and swept volumes. I'd like to introduce today's presenter, Elliot Samuels. Elliot Samuels is a CADfix PPS application engineer. His credentials include a master's in mechanical engineering from the University of Bristol, England. And now, without further ado, Elliot, I'll turn things over to you.
Thank you, Kristen. I'm Elliot, and I'll be presenting the webinar today, the second of 3 in this short webinar series. Each webinar looks at a different functionality of CADfix PPS, our MCAD simplification software. In the last webinar, we covered some of the basic functionality of CADfix PPS, used to quickly remove large amounts of data from MCAD equipment assemblies. Today, we'll look at how we can take this further by simplifying complex solids into primitive and swept volumes. We'll start with a couple of slides to outline the scope of this webinar, followed by a demonstration of CADfix PPS in action, and then a couple of summary slides to finish. So, in this short webinar, we'll be highlighting a small selection of CADfix PPS's tools. Today, as I said before, we're looking at box and cylinder simplification, and also the extrude face tool. And this will demonstrate how we can simplify complex equipment for rapid file size reduction and IP protection. There are a few ways in which we can use these tools. We can interactively select and convert complex solids into primitives. CADfix PPS can also automatically identify appropriate candidates for simplification into primitives. And we can rapidly create swept volumes using the geometry that already exists within a model. After this, there is one subsequent webinar covering process automation and batch processing in some more detail. So CADfix's capabilities. CADfix PPS has functions to simplify CAD equipment, structures like stairways and platforms, and skid assemblies. It does all this by removing a range of unwanted CAD features and parts and converting complex solids into more rudimentary representations. So this model on the right here is a good example of cylinder simplification tool, so the sort of thing that CADfix PPS does. And it does this all through an intuitive interface with wizards for process automation and batch processing. So let's jump straight in and take a look at CADfix PPS in action. I've pre-recorded the processing of 2 models here, and I'll discuss the simplification process as it plays. So this is inside CADfix PPS, and the first thing we have to do is open a model. Here we have a section of some plant equipment. The original file was 177 megabytes. In the first webinar of a series, we removed the small bodies, holes, and internal features, taking the model size down to around 50 megabytes. We'll demonstrate today's tool on the same model, picking up where we left off, and see how much further we can take this data reduction using our box and cylinder simplification tools. So we're shading the model now, and once it's shaded, we'll have a look at just a few things that we did to it last time, and then we'll start on today's stuff. So if we zoom in, we can see here there's no small holes which were left behind by sort of bolts. We've also got rid of the small bodies such as the bolts and washers, and in this box here there were some internal features, and we've got rid of all that, and that took our model down quite considerably in data. And today we're going to be focusing on some further reductions. So we'll start with our box simplification tool. So for our box simplification tool, we can simply select a body and hit apply. And as you might expect, it's turned that component into a box. But there are a lot of these table legs in the model, and we don't want to go around selecting them all individually. So by enabling this pick similar option, we can include bodies with similar mass properties. So now when we select one of these vertical table legs, CADfix will find all 4 and simplify them again into boxes. Leaving this pick similar setting on, we can rapidly populate our selection with appropriate candidates for box simplification. Here, we'll target some of the equipment's frame, as these are pretty good candidates for boxes. Each body making up the equipment's frame has indentations on the outer faces. These intricate details add to the data in the model, and for visualization and clash detection, a box will often suffice, as it's visually quite similar and has the same sort of volume. And it's very quickly turned all of these into boxes and removed quite a lot of data from the model. One more feature of this box simplification tool is the ability to make one box around multiple components. So before, where we were using one box per body, this time round we have a lot of bodies making up the shape of one box. So if we turn this tool on, what we want to do is select all the bodies here which make up this box. So we have this cabinet, we'll select all the frame, we can select the door and the side panels and also the top of it. And we'll turn this make one box around all selected parts on and press apply. In this case, the face colors of these different components that we're turning into one box vary. So it's defaulted to yellow, but these properties can be changed with ease. So if we click on this body and go into the properties, we can change it to, so it was roughly gray before and it had some transparency so that we could see inside. So we'll go gray again and turn it to 50% transparency. The next thing that we're going to look at is the cylinder simplification. So we can simplify bodies that closely represent cylinders or can be represented by combinations of cylinders with varying radii. So the feet of this table is a good example of this, where we've got the base and then the bolt and then the actual leg extended into the table. And you can see it's changed it into a set of 3 cylinders. That's one body with different cylinders of varying radii. A good example of where cylindrical representations can reduce the data significantly would be a set of gears or something like these sprockets. The sprockets have a lot of detail in the teeth, but a cylinder with the same nominal diameter will give a fair representation of that body visually and closely match the original volume. And again, we have a pick similar tool to find bodies of similar mass properties, so we don't have to go and select each one of these. Now at this point, we could continue to interactively select candidates for simplification, but there's a lot more that we can do in this model. And in the case of even larger models, we don't want to invest our own time interrogating every potential candidate for simplification. So CADfix PPS can intelligently determine which bodies can be appropriately represented as primitives. As we've already removed a lot of detail from the model, we only need to run the cylindrical and box simplification tools here in this automated process. I won't go into detail regarding the automatic processing, as I'll be covering how to use CADfix PPS fully automatically and in batch in the 3rd webinar in this series. The progress monitor here displays the different stages of processing. In a second, it will jump through a number of these processes at once. I've cut some time out of the video here for the sake of a demonstration, but the progress monitor will display the total time taken when the processing has finished, as well as some information about the reduction in face count, and I'll highlight that when it's done. So here we can see we've removed 12,516 faces, and it's taken 286 seconds, which is just under 5 minutes. And in total, we've reduced our face count here up to 68.7%, which is quite a lot of the data in the model. And if we look at the model, we can see a lot of primitives now in the place of those complex solids. Table legs and shafts have been simplified into cylinders, and boxes have been used in the place of some bodies. So it's finished off all the frame there. We'll export this now back out to a step file, as that's what we read in, and we can compare it to the original model in the file browser. We have all these other exports on the left-hand side in that list, but as I said, because we inputted a step, we'll export a step so we can compare the file size reduction. So we're going to the file browser, and I'll highlight the 3 files of importance here. So we've got this 177 megabyte one, that was our original file. We've taken that, we've removed small bodies, holes, and internal features, and that's produced this 50 megabyte file here, and that's a 72% reduction. And now today, we've further simplified the model using our box and cylinder simplification tools, taking the file size down to 17 megabytes, and that takes us to a total file size reduction of 91% from our original model. And if we look back at the model, we can see that we've produced a model that closely resembles the aesthetic and volume of the original, whilst containing just a fraction of the data. So in some models, we find very complex bodies, single bodies that contain complex geometry or a substantial number of faces. In this case, a box or cylinder representation may be too crude, but the body cannot be left as it is in its original form, as its complexity contributes significantly to the data count, or perhaps it contains features that need removing for the protection of your intellectual property. And I'll highlight a few examples of this here and hide the rest of the model. So we'll look at these two bodies one by one. This is the first body. This body contains a lot of detail and some complex geometry. It has a connection point with another body at the top where that hole is, and so box simplification probably isn't appropriate here. To simplify these bodies, we'll use the extrude face tool. The user makes a selection from pre-existing geometry to form swept volumes, so you select a face and a point to extrude it to, and there are options to remove holes in the swept volume and to replace the original body. The body we're trying to simplify here is complex, but can be easily separated into some basic sections by eye. We can effectively trace over this model, over the body, forming a set of swept volumes which don't include all the intricate details. Here we can use the loop selection tool to make it easier to form the sweeping face where it may not be accessible on screen. So if we want to extrude this into a cylinder, we can select this loop here and extrude it down. So we'll continue to trace over the rest of this body. As we do this, you can see that we're adding faces to the model. You can see that in the top right, the face count is going up because we're adding obviously bodies to the model. We haven't got rid of the original, but when we do get rid of the original body, this will drop significantly. Here, where there's this hole, we'll extrude this circle back, and we've got the remove holes tool turned on, the remove holes setting. So when we hit apply, we should expect that to disappear, and it has. On the top, we have this hexagon shape. It has surplus details such as the text, the hole, and the fillets. The loop selection can be used here to extrude a more basic feature in its place. And as this is the last extrusion, we'll turn on the replace original body, and that will just delete the original body when we press apply. So we'll press apply, and as you can see, we've got a much more simple shape. We've actually reduced the phase count quite significantly. So we've reduced the total phase count in the model by 5.5% here. That's not just the reduction for this one body, but in the whole model, which demonstrates how significant the contribution to data a complex body can make. We'll have a look at one more example of this. So we have this heat transfer system. It's like a fan and some fins, and this might contain some IP that we need to hide, maybe the blades in the fan or something to do with the cooling fins at the back. Again, here, a box would be too crude a representation, and the body cannot be represented as a cylinder. So we can quickly trace over all the main features using the geometry of the body itself, and then remove the original body. The amount of detail that we capture while using this tool is obviously up to the user. I'm going to include the feet and the boxes at the top here, but this body could easily be made up of two large extrusions for the fan and for the fins. So we've removed the original body. We can see our phase count reduction has gone up to has gone down to 11.9%. So we've removed like quite a substantial amount of data by just processing two of the bodies in this model. I'll change the color here to gray so it's a bit easier to see. And we'll unhide the rest of the model so we can see these simpler representations of the components in context of the whole model. And as you can see, we've retained our general volumes and the aesthetic of each component, and we've taken out a fairly substantial chunk of the data, and we've protected our IP quite quickly. So, CADfix PPS value proposition. CADfix PPS solves MCAD model size problems faced by process plant, marine, and power engineers. It reduces engineering design labor associated with model simplification and integration downstream by up to 80%. And it increases profitability by saving labor costs, avoiding penalties for project delays, and allowing more time to be spent on value-added work. Save days of non-productive geometry handling, increase efficiency, decrease time to market, and get to commissioning faster by employing automated CAD model simplification processes. I hope that this has given some insight into the capabilities of CADfix PPS and what can be achieved in terms of CAD data reduction. If you think that CADfix PPS could be of value in your processes, please register for a free evaluation by following this link. Getting hands-on with the software and processing some of your own data is the best way to see how CADfix PPS can work for you. That's it from me. Thank you for joining, and I will pass you back to Kristen to wrap up.
Thanks, Elliot. Thank you all for joining us today for our CADfix PPS Plant Design Simplification, Webinar 2 of 3. After the webinar today, I will send out a link for you to re-watch this. Also included will be a link for you to register for the third webinar if you're interested. If you have any questions, please email the info@iti-global.com. Thank you, Elliot, for your time this morning, and we look forward to connecting with you all shortly. Have a great day.